Hello friends, welcome back to another video of automationtestinginsider.com, and today I'm going to talk about SDLC. So SDLC stands for Software Development Life Cycle. So it is a process to build any software in a systematic way, and there are different stages are involved in software development life cycle. So what are those different stages? Like we have system investigation, we have requirement analysis, we have design, we have coding, we have testing, and at last we have release and maintenance of the product. So these are the 6 different stages of development life cycle. So do not worry about, guys. I'm going to talk about them in detail in a couple of minutes in my PPT. And there are different stakeholders are involved in any to build any software in any company. Like we have business analyst, we have product analyst, or subject matter experts. So these are the different, more or less the same designation, guys. We have, like, we used to call product analyst in product based companies, or we used to call business analyst in business in service based companies. So, and we have subject matter experts as well. So these are the expert guys in particular area. Like suppose we are going to build a software in finance domain, or e-commerce application, or any other domain. So these are the guys who understands the requirements from the client. And we have project manager to develop the complete project plan of the software or product. And then we have architects who builds the complete framework in the sense like designing of the complete architecture of the software, like high level design or low level design. So I'm going to talk about them in detail in my PPT. And then we have separate dev team for the programming to develop the software. We have development team, and we have testing team as well to test the software. And we have separate release team as well. In some companies we have separate release team, release engineers, they release the software. And then at last we have support guys. After the release we have to maintain the software, or the support of the software. We have separate support guys. So these are the different stakeholders are involved in any software development life cycle. And then we have of course we have finance team as well to discuss about the cost of the software, or the negotiation with the client. We have finance team. And then we have HR team as well for the recruitment of the new resources, or based on the desired skill sets. We have separate HR team, or development acquisition, or talent development team. So these are the different stakeholders are involved in any to build any software, guys. And now let's talk about the different stages in detail in my PPT. So let's get started. So guys, let's talk about software development life cycle in detail. So as I have discussed earlier, like any project development has to follow below phases. Like we have system investigation, requirement analysis, design, coding, testing, and release and maintenance. So these are the different phases are involved to develop any project in the software development life cycle. Now let's talk about them in detail. So what is system investigation phase? So in this particular phase, BA are involved to get the current business scenario or current business process of the customer, to understand their pain points, their issues. So BA is involved in this particular phase. So let's see what it says. So this is an important phase, necessary stage in software development life cycle. Understand the existing business process, as I have discussed earlier. Gather all the data, like what the customer wants to build, who will be the end user, what is the objective of the product. These are all done in this system investigation phase. It is business analyst, as I have discussed, and project organizer's responsibility. Basically, we used to connect with the client frequently with the help of business analyst. The higher management is also used to connect with them to understand their pain points, issues, like what are their expectations from the company. So these are all done in this system investigation phase. So next is requirement analysis. Again, PA will play an important role over here to get the requirement for the upcoming project. for the current project for which we are developing the software development, for which we are following the software development lifecycle, to get the current requirements from the client. So the next stage is to certainly represent and document the software requirements. So this is accomplished through BRD, FRD, SRS, and FRS documents. So what are these documents? So we have BRD. BRD is business requirement document, and it is built by business analyst. We have FRD. It is functional requirement document. So this document tells us like what are the customer requirements to build any software. Okay, so what are the requirements from the customer is documented in business requirement document, and it is done by business analyst. And with the help of BA, we used to pass all this information. We used to give this to the technical team, where all the document will be uh, uh, document will be created in detail level by FRD document, functional requirement document. Like what are the customer requirements is captured in BRD document, and detail level information are captured in functional requirement document. And there is software requirement specification document, and it is developed by architect, system architect. Okay, like we have who is building the framework, define all the software required for the software for the product development or project development. And then we have functional requirement specification. So these are all different documents we have to capture all the requirements from the client. So this is accomplished through BRD FRD SRS document, which contains all the product requirements. The requirement collected two types. What are those two types? So we have functional requirements. It specify the behavior of the application is called the functional requirement, like how our product will behave is called the functional requirement, and non-functional requirements. So we have to capture both functional and non-functional requirements in our documents, like specify the characteristics and feature of the application, like performance, compatibility, and usability, or security. All will be done. All comes under non-functional requirement. We'll talk about them like performance testing, compatibility testing, usability testing going forward. Now here comes the design part. So here system architect or architect involved in this particular phase, and this phase is about to bring down all the knowledge of the requirements, all the documents which we have prepared, analysis and design of the software project. Okay, so we have to analyze it and we have to design the framework. Okay, so in this particular phase, this phase is the product of the last two. Like it is the combination of system investigation plus requirement analysis, like inputs from the customer and requirement gathering. So in this particular phase, we used to build uh, high level design and low level design. So what do you mean by high level designs? So take an example. Suppose I'm a builder and I am constructing a community apartment. Okay, and so there in high level design, what I will do, I'll capture all the high level information, like how it should be, how the community should be, like uh, what are the different what is the high level architecture of the community basically. Like it should have a gym, it should have a community hall, it should have the play area, and it should have like number of flats. So these are all comes under high level design. Okay, and low level design is nothing but like in detail level, like in particular flat, how many rooms will be there, like we are we going to build 2 bhk, 3 bhk, all these information comes under low level design. So system architect divides the design into two parts, high level design and low level design. So these are all done in this designing part, software design part. Now here in this coding, developers are involved. In this phase, the actual development begins and the programming is built. It is the responsibility of the developers to write the coding based on design. Whatever the architects designed the uh, product, Based on that, it's developers' responsibility to write the code. Developers have to follow the coding guidelines described by the management and the programming tools. Now here comes the testing. After the code is generated, it is tested against the requirements to make sure the products and solving the needs address and gather during the requirements stage. So we need to, in this particular phase, we have to create the, whenever we get the from the requirement phase itself, we used to create, the tester used to create the test cases, test plan and test cases, and based on that we used to make the changes when actual testing is happening. So in this particular phase, we execute all our test cases based on the customer requirements, like we have captured whatever we have captured in the test cases in the form of test cases. During this stage, unit testing, integration testing, system testing, and acceptance testing are done. So these are the different testing levels, guys. Unit testing is performed by the white box tester or developer, and then all these testing like integration testing, it is the integration of the different modules. We have system testing, acceptance testing are done in this particular phase. So all kind of testing are performed in this particular phase. And release and maintenance. So once the software is certified, if everything goes well and there are no bugs or errors are stated, then it is deployed into production. And if any issue in the software or any changes required, it comes under the maintenance part. So let's say suppose they customer comes back with their further requirements, or they want to change something in the software, then that will be comes under maintenance part. So taking care of the developed product is known as maintenance. So that is maintenance, and the maintenance of the project can be taken place by supporting or post-production team. So we have, as I have discussed earlier, we have support guys or post-production team who are taking care of this maintenance part. So this is all for today, guys, and please like, share, and if you have any question, then please comment your question in the comment box. And thank you for watching, and please subscribe this channel and click the bell icon to get the notification for upcoming videos. Thank you so much. Hello friends, welcome back to another video of automationtestinginsider.com. So in the last video we talked about SDLC process, software development lifecycle. So in this particular video I'm going to talk about waterfall model. So there are different models in the industry to develop the software. Okay, so to follow the SDLC process, software development lifecycle process. So what are the different models we have in the industry? So we have waterfall model, we have iterative model, we have spiral model, we have agile model, we have derived model, we have prototype model, we have hybrid model. So these are the different models we have in the industry to develop any software. And waterfall model is the traditional model. And yeah, so in this particular video I'm going to talk about what is waterfall model, when to use waterfall model, and what are its advantages and disadvantages. Okay, so let's talk about like what is waterfall model. So waterfall model is a base model or basic model, and it's traditional model, and it's very old model. So it is also called linear sequential model. So if you have seen the last video, like we have certain phases in development, software development lifecycle. Like we have requirement system investigation, we have requirement analysis, design, coding, testing, and release and maintenance. So in waterfall model, we used to follow all these process, all these phases step by step in a linear sequential manner. So this is the reason it is called linear sequential model as well. So it's like waterfall, like from top to bottom, all the phases are in a linear sequential manner. So that's the reason it's like ladder. Okay, so once until unless if one first phase is not completed, we cannot jump to the next phase. So that is the important concept behind this waterfall model, and we cannot come back from the next step to the previous step as well. So we'll talk more about waterfall model in my PPT as well. So this is about the waterfall model and when to use. So when the project is very short, it's not complex, then we can go for waterfall model. And Another thing is, if requirement is clear, then we should go for waterfall model. So I'll take you to my system and I'll show you in PPT like what are its advantage and disadvantages of waterfall model. So let's get started. So let's talk about what are the different software models we have in the industry. So any project development has to follow SDLC phases. So we talked about SDLC phases like requirement analysis, design, coding, testing, and release and maintenance. And based on the size of the project, cost, availability, we can implement different models as per SDLC phases. And each model has its different approach, guys. So let me talk about what are the different models we have. Waterfall model, which is called linear sequential model, we'll discuss about today. And iterative model, spiral model, V model, agile development model. And agile development model is very frequently using nowadays, and it's very important. Prototype model, hybrid model, and derived model. So these are the different models we have in the industry to develop any software. And mainly today we'll focus on waterfall model. And in coming days, I'll explain each and every models, whatever we have listed down here. So let's get started with the waterfall model. So as I have discussed earlier, the waterfall model illustrates the software development process in a linear sequential flow. In the next slide, I'll show you like what do you mean by this linear sequential flow, because there are different phases in waterfall model like SDLC, and that is in linear sequential flow, linear sequential manner. This means that any phase in the development process begins only if the previous phase is complete. And waterfall model is sequential model that divides software development into predefined phases. Each phase must be completed before the next phase can begin with no overlap between the phases. Now let's understand with the help of representation, guys. So I'll draw a diagram so that you can understand it better. So as we have discussed, different phases are there in the software development life cycle. Like we have requirement analysis, design, yeah, so these are the different phases in waterfall model. Like we have requirement analysis, and you can say feasibility study as well. And we have design, coding, testing, and release and maintenance. So the flow is like once requirement analysis and feasibility study is done, so the requirements will be freezed. So the flow will be like this. Then only we can jump to the next part, design part. And once the design is done, design will be done by the architect who designs the complete framework architecture. And once design is done based on the requirements, then developers will start coding. Implementation or coding will be started at that time. And then once coding is done, then tester will perform the testing. And at this point, we'll perform all kind of testing, all kind of system testing, all levels of testing. And then if anything, if we get any defects, then we'll revert it back to coding team, developers, and they will fix the defects. And then last is release and maintenance. Once testing is done, everything is done, if everything is working correctly, then we'll deploy the product. So this is how it looks like, the waterfall model, phase by phase. And it is linear sequential flow because from requirement analysis we are going to design, then coding, testing, and maintenance. So this is in a flow, right, in linear sequential flow. So if you see like waterfall, so waterfall looks like this. Water is flowing, it's flowing from the top to bottom like this in a linear sequential manner. So that's why
waterfall diagram looks like this only, in this way. You don't see like this anywhere in the waterfall model. Okay, so it looks like this because of it represents the waterfall, and we cannot come back once our the phases are done, right? So suppose requirement is done, feasibility study is done, and we jump to the next phase, then we cannot come back and change the requirement. So this is not possible in waterfall model. Same thing over here, we cannot come back and design again from the implementation to the design part. Similarly, for testing as well, we cannot ask the developers to start the new testing for the new functionalities. So this is also not happening, and the last as well. So this is useful for smaller projects. Well, in the next slide, I will understand. Will understand like what when we should use waterfall model. Yeah, and this is the oldest model, traditional model, and this is also called basic model as well. So let's have a look the next slide. So when to go for waterfall model? So when requirements are not changing frequently, then we should use waterfall model. Another thing is application is not complicated and big. As I have discussed earlier, like it should be small project, then we can go for waterfall model. Project is short and requirements is very much clear. Environment is stable and technology and tools used are not dynamic and stable. So these are the different uh, things which for which we should go for waterfall model. Then what are the different advantages of waterfall model? So this model is easy to understand and easy to implement. It is suitable for small and medium sized projects. No change in the middle of the project. So there won't be any changes in the middle of the project. Suppose we want to change any requirement, then this model doesn't allow that. It is suitable for projects if requirements are finalized in the beginning. There are some disadvantages of waterfall model like no feedback path. So what do you mean by this? So in this model, it assumes that no error is ever committed by the developers during any phases. Therefore, it does not incorporate any mechanism for error correction. So once everything is done, we cannot come back in the phase of waterfall model. Once one phase is done, we cannot come back from the previous phase, next phase to previous phase. So there is no change chance of feedback. Not a good model for complex and object-oriented projects. Poor model for long and ongoing projects, and cannot accommodate changing requirements. So it will not take the if requirements are changing frequently. So this is all for today, guys. So thank you for watching. Please like, share this video, and comment if you have any questions. And please subscribe this channel and click the bell icon to get the notification for upcoming videos. In the next video, probably we'll discuss about iterative model. Thank you so much. Have a nice day. Bye bye.
Hello friends, welcome back to another video of automationtestinginsider.com. So in the last video we talked about waterfall model, and we have seen there are some drawbacks in waterfall model. Like if requirements are changing frequently, then we cannot go for waterfall model. And if project is big or complex, then we should not go for waterfall model. And another thing is, until unless if our first phase is not done, then we cannot jump to the next phase, and also we cannot come back from the next phase to the first phase. So these are the main drawbacks of waterfall model. So to overcome all these drawbacks, here we comes for here we uh, go for iterative model. Okay, so what is iterative model? The name says iterative, so it works on the basis of iteration. Iteration is nothing but when we do something again and again, when we perform some task again and again, it's called iteration. So let me explain like what do you mean by iterative model. So take an example, we have some requirements from the customer. Let's say we have XYZ requirements from the customer. Now the first step in iterative model is we should prioritize our requirements. So take an example, in this case I'll first go for the requirement X, okay, and then we'll follow the complete SDLC process like requirement analysis, design, coding, testing, and release and maintenance. So I have picked one requirement at a time like X, and then we follow the waterfall, like what are the different SDLC phases we have: requirement analysis, design, coding, testing, and release and maintenance. Release. Okay, so we'll follow all those steps and we'll deliver the first build of software, working software. So this is first iteration. Now after getting the feedback from the customer, getting the feedback and reviews from the customer, will work for the requirement Y. Now again we'll perform the same task like requirement analysis, design, coding, testing, and release. So this is iteration 2. Similarly for the third requirement, that is Z, XYZ. So the last one is Z, so we'll work for the will follow the same process for requirement Z. So we'll follow the same procedure again and again till we gets the final build. So this is how iteration works. Okay, this is called the iterative model. So let me take you to my PPT where we'll discuss like some of the theoretical stuff of iterative model, and also discuss about pros and cons of iterative model, and I'll explain you better with the help of diagram there. So let me take you to my PPT.
Guys, let me just recap what we have discussed at the beginning of this video, some theoretical stuff, so you can make a note of it, like what do you mean by iterative model, how it works. So we create rough product or product piece in one iteration, then review it and improve it in the next iteration, and so on until it's finished. So we work on the basis of it works on the basis of module, like module wise, and then we'll get some reviews from the customer. So we'll work like module 1, 2, 3, and so on till we get the final build. And in the next slide I'll show you with the help of example whatever we have discussed at the beginning of this video. So the basic idea behind this method is to develop a system through repeated cycle, iterative, and it is, and in a smaller portion at a time, incremental. So this is also called incremental model. Okay, so this is the combination of iterative plus incremental. Why it is called incremental? Because it increments the requirements, like module 1, module 2, we got some other requirements, and then module 3. So we and incrementally adding all those requirements, those modules. So that's why it is called incremental module as well. Now let me explain with the help of an example. So suppose we got some requirements from the customer. Take an example, this is requirement x1, y1, z1, x2, y2, z2, and x3, y3, z3. So these are the requirements we got from the customer. Now we'll follow the SDLC process, the complete SDLC process to build the software. So in the previous slide we have seen like we have to deliver the first working piece of software. We'll follow the complete life cycle like requirement analysis, then design, then coding plus testing, and then release and maintenance. And at last we get the feedback and reviews from the customer for this build. So this is complete one process, guys, and this is called build one. So do not worry about the build and release. I'll create a separate video. What do you mean by build and release? So we followed the first module. Will and this is consider this is module 1. Okay, consider this is module 1. This set of requirements under module 1. Now we followed the complete steps. So this is called iteration 1. Iteration 1. Now we got some feedback from the customer and reviews, and will work based on those reviews and feedback. Will work on module 2. We'll keep we add those feedback and reviews in module 2. Okay, suppose they want to make some changes in module 1, so we'll make the correction and will integrate with module 2. Now we develop module 2 along with module 1. Now we'll follow the same procedure again and again, like requirement analysis, design, coding, testing, and release. So this is iteration 2. Now again we'll get feedback from the customer, reviews from the customer. Okay, now we'll develop module 3. So we'll keep adding module 1, 2, 3 and so on till we get our final build, final product. So this is how it works, the iterative model. It is called incremental. Why? Because we keep adding module 1 plus module 2 plus module 3 and so on. That's why it is incremental. And iterative because this is we follow the same procedure again and again. Okay, so this is one SDLC process, iteration 1. This is again we followed the SDLC phase, iteration 2, and this is iteration 3. So this is about iterative model. And another thing is, like, module 2 can start parallelly as well. Suppose we have already working on module 1, now we can start module 2 as well at the same time. Maybe after it reached over here coding phase, then we can start parallelly module 2 as well from requirement analysis. So it can run parallelly as well, and it works for the project which has multiple modules. Like in this case, we have divided into 3 different modules. So this is how it works, guys, iterative model. Now let's talk about some advantages and disadvantages of iterative model. So testing and debugging during smaller iteration is easy. We have divided into different modules, so debugging is easy in this case. It is easily acceptable to ever-changing needs of the project. So this is the biggest drawback in waterfall model. Like, we cannot change the requirements, we cannot come back and change the requirement, but here we can accept the requirements. Limited time is spent on documentation and extra time on designing. So this is an important point. So we spent less time on documentation and extra time on designing. Risks are identified and resolved during iteration. So whatever risk we'll get, we'll talk about risk in the next model, that is spiral model. More about some more points about the risks. However, I'll create a separate video on risk because because we have a complete tutorial on risk as well, because that is separate part. So risks are identified and resolved during each iteration. So what are the different disadvantages of spiral model? So it is not suitable for smaller projects. So since we have divided into different modules, and we work on the basis of SDLC, and we followed module wise concept. So if cost will be increased if we follow this for smaller projects. Okay, so maybe it will not applicable for small projects. Design can be changed again and again because of imperfect requirements. So if you don't get the correct requirements, then design can be changed again and again. So this will cost this will double the budget of the project. Requirement changes can cause over budget, the same thing. And then project completion date not confirmed because of changing requirements. So yeah, completion date is not confirmed because of the changing requirements. So these are the drawbacks of uh, spiral model, sorry, iterative model. So in the next video, guys, I'm going to talk about spiral model. So thank you, guys. Thank you so much. And please like, share, and comment if you have any questions, and subscribe this channel and click the bell icon to get the notification for upcoming videos. Thank you so much. Have a nice day. Bye bye.
Hello friends, welcome back to another video of automationtestinginsider.com. So today I'm going to talk about spiral model. So in the last two videos we talked about waterfall model and iterative model. So if you have not watched those videos, then please I would recommend please watch those videos and come back to this video, because until unless if you don't understand like what is waterfall model and what is iterative model, you cannot understand spiral model. So it's important to go and watch those videos. So I have given the link in the description box of this video, the complete playlist link. You can go and watch those videos and come back to this video. Now let's talk about what is spiral model. So we have seen there are some drawbacks in waterfall model and iterative model. So to overcome all those drawbacks, here we go for spiral model. So what do you mean by spiral model? So spiral model is the combination of waterfall model and iterative model. Okay, so let me take you to my PPT where we can understand better with the representation of spiral model, and we'll see some notes about spiral model and pros and cons as well. So let me take you to my PPT and understand better like what is spiral model.
So guys, as we have discussed at the beginning of this video, like a spiral model is the combination of waterfall model and iterative development approach, iterative model. So let's talk about some of the points about a spiral model. So you can make a note of it. And in the next slide, I'll show you with the help of diagram, we'll understand better like what is a spiral model. So let's get started. So it is incremental development approach. It is incremental development approach. So you have seen in iterative development approach, like we used to develop the product based on the requirements. Like we prioritize the requirement and we develop module wise, module 1, module 2, like that. So that's why it is called incremental development approach. The project is developed phase by phase. Phase by phase, the new requirements are integrated to the existing application. So as I have discussed, like module 1 we have certain requirements, and then in module 2 we'll add some more requirements, and so on. The requirements are prioritized based on business requirements. This is a risk driven software development process model. So as I have discussed, like this is the combination of waterfall model and iterative development model, but there is an extra factor like risk analysis. So it's risk, there is a high percentage of risk analysis in spiral model. So it is also called like risk driven software development process model. So it is suitable for large and complex projects. This spiral model is the combination of iterative development process model and sequential linear development model, that is waterfall model, with a very high emphasis on risk analysis. So this is these are the some notes about spiral model. Now let's talk about in detail like what is a spiral model with the help of diagram. So there are four phases uh, in spiral model. So first phase is planning. We have first phase is planning, and then we have risk analysis. Third would be coding and testing. Or you can call it as engineering as well, engineering, or you may call it as implementation, implementation. Or so the third phase you can call it as coding and testing, or engineering, or implementation, and the fourth one would be evaluation. Evaluation. So evaluation is done by customers. They'll provide the feedback. So let's start with the planning phase. So yeah, it starts from here. So suppose we got some requirements from client, and in this particular phase, planning phase, what happens is BA works with customer to get the requirement, and with the help of project manager, they used to estimate the project and do the complete the planning of the project. So let's say we have divided our requirements into different modules. So right now we are working on module 1. This is module 1. So this phase will start like this. Now we need to do risk analysis for the module 1. So we'll do risk analysis over here. So first of all, we need to understand like what is risk. So risk is the possibility of something bad happening, and you can say like it involves uncertainty, uh, events like it may or may not happen in the future. So there are certain phases in risk, like certain steps to resolve the risk. Like we have identification of the risk, evaluation, prioritization of the risk, and there could be different project related risk, like scope related risk, and cost related. We have schedule related as well, and lack of clarity in the requirements, resources unavailability. So these are the different risks we have. Cost related means if cost is the at higher side, so that will be a risk. We'll do all kind of risk analysis in this particular phase. So do not worry about guys like risk, because risk analysis is a separate topic we can discuss later on. So for now you can understand like these are the different risks, like whatever I have talked about related to project. So we'll do all kind of analysis over here. So risk analysis for module 1 is done. Now coding and testing will be done over here. So whatever requirements we got, we'll do the coding. Developer will do the coding, and they will implement the coding, and then they'll send it to testing team for testing that particular module. So we'll do the testing of module 1 over here. After successful once successfully tested module 1, then we'll go for the release, and we'll do the release over here. So module 1 will be released over here, and based on customer reviews and feedback, we'll work upon module 2. So we may add some more requirements. We can change the requirements from module 1. We can update the requirements of module 1, and we'll work with the new requirements from module 2, and then we'll start module 2 over here. And then same process will go like this. Planning phase, again we'll do the planning for module 2, and the same thing like risk analysis for module 2 will be done over here. And then coding of module 2, and developer will integrate module 2 with module 1, and we'll do integration testing of module 1 plus module 2 over here, and we'll do regression for module 1. So we'll make sure that the changes of module 2 does not affect the module 1. So that's the reason we do the integration and regression testing over here. Do not worry about different testing like integration or regression testing. We'll discuss in coming videos. So once testing and everything is done for module 2, and then we'll deploy module 1 and 2 over here. Module 2, 1 and 2 integrated and we deployed successfully, and will work for module 3 over here. So this is how we'll keep working on module wise. So let's say this is module 3. Now again the same process will start planning of the module 3, and then we'll do the risk analysis for module 3, and then again we'll we'll do the developer will integrate module 1 and 2 with module 3, and we'll do the integration testing between among module 1, 2 and 3, and then we'll do the regression testing, like module 1 and module 2 does not get impacted, and so on. This process will go. So this is a spiral model, guys. So this is the combination of like iteration. Like iteration is there, you can see here, like we have iteration is nothing but repeatable things. So we are repeating the same phases like planning, risk analysis, coding and testing, and evaluation. We have 4 phases over here. So we will keep repeating all these phases. So that is iteration in a spiral model. And incremental is nothing but we are adding module 1 with module 2 and module 3. So this is how we are developing the software. So this is about spiral model. Now next we'll discuss like when to use a spiral model. So when deliverance is required to be frequent, so we'll get when we get the frequent requirements from the customer, so we should go for spiral model. When project is large, of course, and when requirements are unclear and complex, so we can go for spiral model, because in this particular model there is high risk analysis, so we can take the requirements in the middle as well. So what are the different advantages of spiral model? The requirement are prioritized based on the business requirement, so that is the advantage we have. We can prioritize our requirements, like from whatever requirements we got from the customer, we can prioritize them and we can work upon those requirements. It is suitable for large and complex projects. There are some disadvantages of spiral model, like can be a costly model to use, because as I have discussed earlier, like we have to do high level of risk analysis, so it could be a costly model. Risk analysis needed highly particular expertise. Doesn't work well for smaller projects. So in smaller projects we cannot afford the high cost, so it won't work for smaller projects. So this is all about spiral model, guys. So in case if you have any questions or anything, please comment it, and please like and share this video, and please subscribe to this channel and click the bell icon to get the notification for upcoming videos. Thank you so much. Have a nice day. Bye bye.
Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about the comparison between waterfall model and spiral model. So already we have discussed about waterfall model and spiral model. So if you haven't watched those videos, then please go to description box of this video, and I have provided the link in the description box, and you can watch those videos and then come back to this video so that you can understand the comparison between waterfall model and spiral model. So let's talk about, I'll take you to my PPT, and where we'll discuss like what are the different factors about, we'll see the comparison between waterfall model and spiral model on different factors. So let's get started.
So guys, let's do a comparison between waterfall model and spiral model, and we'll see some differences as well. So I'll create 3 columns over here. One is for properties, like on what basis we'll do the comparison. So this is property on basis of what we'll see the differences, and we'll do the comparison. This is waterfall model, waterfall, and this is spiral model, spiral column, spiral model column. So let's see the first point, definition. So what is the definition of waterfall model? It is linear sequential model, or base model, or traditional model, and what is spiral model? This is risk driven model. You can make a note of this, guys. I could not create PPT on this like with the notes. That's why I'm writing some of the differences over here. So you can make a note. However, don't worry, I'll put it the complete notes in my blog later on. So the second is flow of the process. What is the flow of the process? So waterfall, what happens is after completing a phase and reach to the new phase, it is not possible to go back to the previous phase. Suppose this is phase 1 and this is phase 2, 1 and 2. So once we reach to phase 2 from requirement analysis, let's say this is requirement analysis and this is design. So once we reach to second phase, we cannot come back from the second phase to first phase. And here it operates on the basis of iteration. It operates on the basis of iterations, as we have seen in iterative model or spiral model. We have seen like how it iterates. So we have different modules in spiral module, and we'll follow the same process again and again. So that is nothing but the iteration. Now the third point. What is the third property? Customer involvement. Customer involvement. So here in waterfall model, it's very minimum because our steps and everything are fixed in waterfall model. Here customer involvement are more because the customer has an awareness of what the product is. So customer involvement in spiral model is more. What would be the fourth point? Fourth point is the usage. So this is for small projects, and this is for large and complex projects or big size projects. Flexibility. Fifth point is flexibility. So this is, it is not flexible. Okay, this is not, it is not flexible. And whereas in spiral model is flexible because it works on the basis of iteration. So we can change the requirement anytime, or it is more flexible. We have different phases in spiral model and iteration as well, as I've discussed earlier. So this is about flexibility. Changes in the requirement. One of the property. So here changes is not possible. Here changes are possible. Here changes are possible. Seventh one is cost of the module, like how much expensive waterfall model or spiral model. So this is less expensive compared to spiral model, and this is very expensive because here manpower requires a lot,
and team strength. Yeah, team strengths are needed, like more team members required here. And because we have a separate things like risk analysis, so for that we need expertise to analyze the risk. So this is the seventh point, and the last one is risk involvement in waterfall or spiral model. That is eighth point, risk. Waterfall model is high risk. High risk are involved in waterfall model here. Less risk in spiral model. Why high risk in waterfall model? Because we have certain phases, and there is it's in linear sequential phase, and once a phase is done, we cannot come back or change the requirements, or we cannot come back to the current phase once it is done. So risk involvement is high because the requirement may, if customer is change the requirement or anything happens in the future, so it's very risky model, I would say. Whereas spiral model, because we used to take the feedback and reviews from the customer, and it works on the basis of iterations. We divide the requirements, we prioritize into different modules, so risk is very less over here. And we do the risk analysis. The model itself called as risk driven model. So these are the different properties we can differentiate waterfall model and spiral model, guys. So I'll put this notes clearly because this is not visible, I guess. So I'll put in my blog, that is automationtestinginsider.com. Don't worry about that. I'll put it in my blog in coming days. So thank you guys for watching. This is all for today. Thanks a lot. Bye bye. Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about what do you mean by verification and validation, and what is the difference between these two. So before I start V model or V and V model, it's very important, very important to understand like what do you mean by verification and validation, and what is the difference between them. So let's talk about like what do you mean by verification and validation today, and difference between them. And then probably next video I'll talk about V model so that you can understand better. So before I take you to my PPT where we'll understand the proper definition and difference between these two, let me give you an example so that you can understand, you can relate better, like what do you mean by verification and validation. So suppose you are buying any product from any e-commerce website. Take an example, Amazon. So what you're gonna do, first thing is you open the browser or open the app, and you will select your product based on your need. Like suppose you want to buy a t-shirt, so based on your size, the brand which you want to from which you want to buy, you select that brand, and then color you choose as per your choice, and then you do add to cart. Now you added the product in the cart, and from there, before making the payment, what you're going to do is you'll verify all those things, like whether I have selected the proper size or not, the color which I have selected earlier, it's fine or not, and then address where it will be delivered, the where address is proper or not, and the price also. If you have any kind of coupon code or something, you apply that also, and verify the price at the end, like how much charge it is going to cost you, right? I mean, how much is the cost of the product with the delivery charge and everything. And another thing is you'll see the return policy as well. So these are the different things you verify before making the payment. So these are the things is nothing but a verification, because you did not get the product yet, but you verifying all these things by just seeing the product. So this is nothing but the verification. Now once it is delivered to your address, what you're going to do is you'll test that, right? And by wearing that product, let's say t-shirt, so you'll verify like how is the size, how is the color looks like, and everything. So if it is not suitable for you, then you'll return it, because earlier you have verified the return policy and all. So after getting the product, you will do the actual testing of the product. So that is nothing but the validation. So this is the difference between verification and validation. So same thing happens in case of verification and validation in testing. So I'll take you my PPT. I'll take you to my PPT where we'll understand like what do you mean by verification, the proper definition of verification and validation, and difference between them. So let's get started. So guys, let's talk more about verification and validation. And at the beginning of this video, I have given a very good example of verification and validation. So before getting the product, whatever you do, the investigation is nothing but the verification. And once you get the product, whatever you do, the investigation is nothing but the validation. So same thing happens in software testing as well. Software testing, verification and validation. So before I start the V model, it's very important to understand verification and validation. So in coming days, I'll talk about V model. So let's focus on verification and validation as of now. So here I have listed down the difference, the definition of verification and validation and difference between them. So verification is the process of checking the document like BRD, SRS, CRS, customer requirement specification, design, code, and programs. And validation is testing and validation of actual product. So if you see like V model, we have one side, this is nothing but the verification part, and this is validation part. So I don't want to talk more about the V model as of now, but this part, the left side part is called the verification and the right side is validation. Here is the left side is also called SDLC. It is the part of software development lifecycle process, and this is part of SDLC, testing lifecycle. So here in SDLC, like we have requirement gathering, the design, coding, all these phases comes under SDLC. So verification is the process of checking the documents, different requirement documents, design, coding, and programs is nothing but the verification. And actual testing, once we get the product, testing and validation of actual product is called validation. Now the proper definition, like are we building the product right? That is the proper definition of verification. And in another words, software meets the specification or not. Here we talk more about the specification of the product. Here we are checking whether we are developing right product or not. And if you talk about validation, are we building the right product or not? Software meets the requirements. Here we talk more about requirement or not. We check whether the developed module is right or not. So this is the difference like in terms of definition. And the second thing is, third point is static testing. This is comes under static testing, and this is dynamic testing. So in the next slide, I'll talk more about like what are the different methods of static testing and dynamic testing. So these are the different methods, guys: inspection, reviews, and walkthroughs. So these are the part of static testing. Basically here we review the document, walk through, we go through documents, inspection, all these comes under static testing. And here in validation we have unit, integration, system, acceptance, all levels of testing. These are 4 levels of testing, probably we'll discuss later on in detail, but just for your understanding, like in validation we follow all the levels of testing as well as all functional and non-functional testing in validation part. And here QA comes under verification, QC comes under validation. So here you can see in V model we have this part as quality assurance and this part as quality control. So in the next video I'll talk about what do you mean by quality assurance and what do you mean by quality control. So left side is called quality assurance, right side is quality control. And QA involved here, like quality assurance analyst involved in verification part. So probably you have heard the CMMI process. So there are different CMMI process areas are there. So based on the company's level, like level 3, level 4, level 2, whatever, level 5. So we have certain process areas. So that is a different chapter, guys. Probably we'll discuss later on only. So based on the
level of CMMI, they follow the QA used to follow the process areas. We have different process areas, and they'll prepare the documents. They'll track the projects progress and all. Metrics will be there. So a lot of factors are there in QA, in QA's responsibilities. And here tester involved with the help of QA. So here the actual testing process is done in validation. So of course testers are involved with the help of quality analyst. Seventh point is it comes first before validation. So verification comes before validation. So it comes later, and it finds the bug early in the development life cycle, and it finds the bugs that verification cannot catch. So when we start the development process, so whenever if you get any bug related to if requirement is not is matching, I mean requirement is ambiguous, or it is not matching as per the customer needs, so we can raise the defects, bugs early in the development life cycle. Whereas in once we get the product, we do the actual testing, and there mostly functional and non-functional related defects will get. So this is the difference between verification and validation. So thank you guys for watching. Please like this video, share it, and comment if you have any questions, and subscribe to this channel and click the bell icon to get the notification for upcoming videos. Thank you so much. Have a nice day. Bye bye.
Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about what do you mean by quality assurance and what do you mean by quality control and what is the difference between them. So I'll take you directly to my PPT where we'll discuss what is the difference between what do you mean by quality assurance, quality control, and what is the difference between them. So let's get it started.
So guys, let's talk about quality assurance QA and quality control QC. But before I start quality assurance and quality control, let's talk about what do you mean by quality. So in simple terms, quality means if any product is fit for our use or fit for our purpose is called quality. So it's all about meeting needs, expectations with respect to functionality, design, reliability, and price. It's called a quality product. And what do you mean by assurance? So assurance is nothing but kind of positive declaration of a product or service which gives us confidence. So that guarantees that gives the guarantee that this product work without any problem. That is nothing but the assurance. So in software terms, how do you define quality assurance? So it is a procedure to ensure that the quality of software product or products or services provided to the customer is called the quality assurance. And quality mainly focuses on improving software development life cycle. In the last video, we have seen one side of the V model is called the verification and the other side is validation. Similarly, this part is called quality assurance and this is quality control. So here we have software development life cycle. Here we have testing life cycle, software testing life cycle. So QA mainly focuses on improving software development life cycle. And nowadays this QA becomes SQA as well, software quality assurance. Now what are the different stages of quality assurance to make sure that quality assurance take is on place in any company? So there are four steps, like we have plan, do, check, and act. Plan, do, check, act. So in planning, what we do, we should plan the process related objectives, process related activities. We should plan process to make sure all the process is on place. Do is nothing but do changes to the existing process, or the development of the new process is called the do. Check what we do, monitoring the process. It is monitoring the process, monitoring the process. And act, take actions to improve the process. So this is act is nothing but the improvement. Do is kind of changes to the existing process or development of the new process. So these are the 4 stages involved in quality assurance, guys. And there are some certifications in quality assurance. Probably you might have heard about CM level, CMI level, and we have ISO 9000. So these are the quality standards certifications which company used to do. When we call, like, if any company is like same level 3 or 4, right? So company has to follow certain process areas. If it is same level 3, then there are certain process areas which company has to follow. So who will handle this quality assurance process? So company used to hire quality analyst who will take care of all the quality assurance related activities, all the process areas. They will make sure that every documents, everything is on place. And they used to prepare the templates as well. We cannot use any template without any without certification. We cannot use any templates. That has to be as per the process. Take an example. Suppose we want to use any uh, test case summary document, or test case authoring document, test cases document, or test plan. All should be certified by QA, and the proper template should be there. And in sim level, if you have, probably you might have already aware, we have 5 stages, like initial, repeatable, defined, managed, and optimizing. So those are the 5 different stages of sim level. Now let's talk about quality control. So the other side of the V model. V model we'll discuss later on. So just to explain you guys, like what do you mean by QA and QC, that's why I took the help of this V diagram. Now let's talk about QC. What do you mean by QC? So QC is nothing but it's a software engineering process to ensure quality in a product or service. So basically it examines the end product once product is developed. So this is like quality assurance is part of when product is going under development phase, and quality control comes under once product is done, the testing part. It's nothing but quality assurance, and this is handled by uh, tester. This is handled by the software tester with the help of quality analyst, with the help of you guys. So this is brief about quality assurance and quality control. Now in the next slide, let's talk about the difference, the more difference between them. A couple of difference I can talk about it, like this is process oriented quality assurance, and quality control is product focused. It is mainly focused on the product, and this is mainly focused on process. And this is preventive technique. Quality assurance is preventive technique, and quality control is corrective. What do you mean by that? So preventive is it prevents the defect, and it corrects the defect. So in the next slide, let's talk about more about the difference between quality assurance and quality control. So QA is the process of managing the quality, managing for the quality. So that is quality which we have discussed. Quality control is used to verify the quality of the product. Quality of the product. QA aims to prevent the defect. This is what we have discussed. And QC aims to identify and fix the defects. So in testing, what we do, we raise the defects and get it fixed from development team. So QC aims to identify and fix the defect. It is method to manage the quality verification. It is method to verify the quality validation, which I have spoken about in the last video. One part of V model, one side of the V model is called verification, and other part is validation. So the left side is called verification and right side is validation. So here this is quality assurance and this is quality control. It is preventive technique. It prevents the defect. It is corrective technique. It is process to create the deliverables. It is process to create the deliverables means QA guys will help us to prepare all the templates which I have discussed earlier, like test case summary template, test case document, test case template, test plan, defect report, defect summary report. All these documents are prepared by QA guys. So it prepares the deliverables. It is the process to create the deliverables. It is the process to verify the deliverables. So we used to prepare all these documents and we'll verify, right, whether it is working correctly or not. I mean, when we write the test cases, so we verify all those deliverables. And QA is part of SDLC. Mainly it's part of software development lifecycle, and QC under software testing life cycle. Involvement of whole team, and here testing team. Generally QA also involved here, like quality assurance people, quality analyst, perform before QC and it performs after QA. So this part anyway, this is software development lifecycle SDLC. So this will happen first and this is afterwards. Once product is ready, then software testing lifecycle. So yeah, this is all about QA and QC guys. And there is another term called quality engineering, QE. Probably we'll discuss more about quality engineering later on. So in case if you have any questions, then please let me know. So thank you guys for watching. Have a nice day. Bye bye.
Hello friends, welcome back to another video of automation testing insider.com. And today I'm going to talk about V model, or you can say V and V model, or verification and validation model. So guys, already I have spoken about verification and validation and quality assurance and quality control. So if you haven't watched those videos, I would recommend first go through those videos and come back to this video. However, I have provided the link in the description box of this video. I have provided the complete playlist of manual testing as well as software development models. So you can watch, you can check out them and watch them, and then please come back to this video. So let's talk about V model today. So why it is called V model? So here all the phases which are involved in V model are executed executed in a V-shaped manner. So that's why it is called V model, and it is an extension of waterfall model, where each phase of testing is associated with development phase. So I'll take you to my system guys, where we'll discuss more about V model, what are the different advantages of V model and disadvantages. So let's get started.
So guys, let's talk more about V model. So the V model is type of software development lifecycle model where process executes in sequential manner in V shape. It is also known as verification and validation model, which we have discussed earlier. So sequential manner in V shape means like this. So that's why it is called V model. The V model is an extension of waterfall model and is based on association of testing phase for each corresponding development phase. So this part of V left side is called software development lifecycle, and this is software testing lifecycle. This belongs to the development team, and this is belongs to testing team. And what is the next? This is highly disciplined model, and next phase starts only after completion of the previous phase. So it is like waterfall model, guys. So we cannot jump to the next phase until unless this phase is completed. But corresponding we have testing phase. So you can understand the next slide better, where I'll talk more about a V model, the pictorial representation of V model. And this part of V is also called quality assurance, and this is quality control, this is verification, and this is validation. The left side part is called verification and right side is validation, which already we have talked about in the last video, previous videos. So let's talk more about V model, guys. So let me just draw a diagram in V shape like this. Now what is the first thing? We get the requirement from the customer in the form of CRS, customer requirement specification. So this is dev team and this is testing team. Now we got the requirement from the customer with the help of BA. BA will work with customer, business analyst will work with customer to get the requirement and got the requirement. Now BA will convert that requirement into BRD document, business requirement document, and with the help of manager it will be given to development team and testing team. Now what tester will do here? They will do three things. They will go through BRD and they will create acceptance test plan, acceptance test plan, and they will create acceptance test cases, acceptance test cases. And while going through all these phases, like going through the BRD, creating the acceptance test plan or creating the acceptance test cases, if they find any ambiguity in the requirement or if they need clarification, so they can contact with the dev team with the help of business analyst. Yeah, they can contact with the business analyst, project manager, to get the clarification of the BRD, business requirement document. Basically they will compare, they will get the CRS also, customer requirement specification, and they will compare with BRD here, testing team. And this level of testing is called acceptance test. So do not worry about different levels of testing, guys. I'll talk about more in coming videos. So this level is acceptance test. Now what is the next phase? BRD will be converted to SRS with the help of architect. The BA will convert that into, with the help of project manager and architect of the project, will convert that into SRS, software requirement specification, and it will be given to both development team and testing team, because development needs to understand the software requirement specification, and that at the same time it will be given to testing team as well. So what is the next for testing team? So they will compare both like SRS document with respect to BRD, and they will go through SRS document, software requirement specification. They will create system test plan and system test cases. I'll talk more about like how do you create the test plan, guys, test plan and test cases in coming videos. Do not worry about that. So just understand, like they will go through the software requirement specification with respect to BRD. They will compare. In case if they find anything, they can revert it back to the development team, and the tester at the same time will create the test plan, system test plan, and system test cases. And this level of testing is called system test. Now what is next? So here HLD, who will create high level design. So HLD will be created over here with the help of architect, who creates the framework or create the high level design document. SRS will be converted to high level design document, and it will be given to both development team as well as testing team. Now here tester will compare high level design document with SRS. So already I have spoken about high level design, what is high level design, low level design, software requirement specification, BRD in previous videos guys, you can refer those videos. Now here tester will go through high level design and they will create integration test plan over here, integration test plan and integration test cases, integration test cases, and this level of testing is called integration test. Now what is next? Now HLD will be HLD will be converted to low level design. HLD will be converted to low level design, that is LLD, and it will be given to testing team as well. Testing team will compare low level design versus high level design. Like high level design is converted properly to low level design or not. If they find any discrepancy or any mismatch things, then they can revert it back to development team. Now here tester will this is functional test. Here it will come functional test. Now here what tester will do, they will create the functional test plan, and functional test cases, and anyway they will go through the low level design document here, and they will create functional test cases and functional test plan, and they will create functional test cases. Now what is next? Now developer will do the coding over here, coding with the help of low level design document, and now this will be given to the testing team as well. I mean, they will release the software to the testing team. Before releasing, they will do here white box testing, and or else you can say unit level testing, unit test. So this white box testing or unit level testing is will be done with the help of either developer or white box tester. Now we got the software guys here, we got the software. Now that will be given to the it is given to the testing team. Now what tester will do, because once unit testing is done by the development team or white box tester, now the software is ready. Now we'll execute our functional test cases because it is already ready over here. After completing the functional test cases, we will revert we will go for integration test of all the modules. In case in this process if you get any defects or anything, then we can raise it in our defect tracking tool and we can get it rectified from development team. Now after integration test, we'll execute system test, and at last we'll execute the acceptance test. So this is the complete flow of V model guys. So one second. Yeah, so this is the complete flow of V model guys. So let's talk about the next point in the slide. So when to use V model? So the project is short, requirements are well defined, clearly documented and fixed, product definition is stable, and there are no ambiguous or undefined requirements. So this is like V model. When we go for V model, waterfall model, when we have when the project is short. So this is also useful for short-term projects. And what is next? When to use is done. What are the different advantages of model? So start testing from beginning of the project. So you can see we have seen in that slide when I have drawn the diagram of model. So each testing starts from the beginning of the first phase, from the beginning of the project. So that is an advantage of model. Testing include both validation and verification. Defect found at early stage cost, so that cost of fixing defect is very less. So because each phase we are verifying the documents, different documents, so that's why cost of fixing the defect is very less, because we'll get very less defects when we do the actual testing in model. As testing is more involved from beginning, better understanding of the requirement. So these are the different advantages. What are the disadvantages? Not a good model for complex and object oriented project. So if it is big project guys, it will be, the process is very complex, right? So this process itself is complex, so it is not useful for big project or complex project. Poor model for long and ongoing projects. Not suitable for the projects where requirements are at moderate to high risk of changing. If requirements are changing frequently, so this model is of no use. I mean, it's very hard to go for model. Once an application is in the testing stage, it is difficult to go back and change a functionality. So because we have already gone through all the phases of development lifecycle, and once it is delivered to the testing team, after the unit testing, we have seen integration unit testing over here, and then it is very difficult to go back and change that functionality, because we have already gone through lots of stages, and more documents are required. More documentation are very high here. Documentation, we have to create lots of documentation, process documents. We have to go through all the process documents. So these are the different disadvantages of model. No working software is produced until late during the life cycle. So in this phase, the software is not yet developed. It is developed after certain stages only. So these are the drawbacks of model, guys. So thank you for watching, guys, and please like and share this video and comment if you have any questions, and please subscribe to this channel and click the bell icon to get the notification for upcoming videos. Thank you.
Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about an important software development model, that is Agile Model. You can call it as Agile Development Process Model, Agile Process, or Agile Methodology. And this is a very important software development model which is widely used and frequently used by different software development companies. And this is you should aware of what is the agile process. Every QA must know about this process, and this model is mainly focused on the delivery of the software, the frequent delivery of the software to the customer, irrespective of the documentation. So we mainly focus on the delivery of the software to the customer. Now in agile model, like we have seen in different software development models earlier, like waterfall model, spiral model, V model, there were some drawbacks. So all those drawbacks are overcome by this software development model, which is agile model. Now there are different terms we have been using in agile process, and there are different meetings as well. So I'll take you to my system where we'll discuss more about like what is the complete process of agile development process model. So let's get started. So guys, let's talk more about agile development model, or you can call it as agile methodology or agile process model. Now there are a couple of things which is very much important in agile, like continuous delivery of this software to the customer, and the second thing is handle
the requirement change. So these are the two important concept of agile development model. So unlike in previous models, we have seen uh, we mainly focus, I mean, we have done so much on documentation part, and they are not capable enough to handle the requirement change. But here in agile development model, we mainly focus on continuous delivery of the software to the customer and handle the requirement change, handle the frequent requirement change in the software. So these are two important points about the agile development model. Now there is a certain process to follow the agile development model. There are certain stages. Now take an example, we got the project from one customer and duration of that project is 1 year. Now we divide, customer wants the software in every 2 weeks. So we'll divide the software, we'll divide the complete requirements into different modules. So like this. So take an example, this is X, this is Y requirement, this is Z. So we have divided the different requirements into different modules. So each module, they want the software in every 2 weeks. So that 2 weeks duration is nothing but our sprint cycle. So sprint cycle is of 2 weeks. So every 2 weeks we'll release the software to the customer. Now in that 2 weeks we have to follow the complete agile process. So what are the different steps we have in agile process model? So in agile development we have planning of the sprint, we have design. So design we have seen like high level design, low level design we have discussed earlier, and then we have development, develop, and we have testing the software, and release, and last feedback. So this is the complete process of agile development model, guys. So we have planning of the particular sprint, and then design, we'll do the design, and development or coding you can say coding, and testing of the software, release the software, and get the feedback from the customer. Now, so this agile development model is also called iterative. I mean, it is the combination of iterative development plus incremental. Why it is iterative? Because what do you mean by iterative? So we have seen in iterative development model, when we keep doing the same thing again and again is called iterative. So this is my module 1 or sprint 1. So we have followed plan, design, develop, test, release, and feedback. So similarly we'll do for, so this is sprint 1. Now we'll follow the same for sprint 2 as well, sprint 2 cycle or module 2. So that's why it is iterative development model plus incremental. Why it is incremental? So we have divided our task into different modules. So we have divided our task into different module. So this is module 1. We made some changes on module 1. I mean, we have developed some some requirements on module 1, and we'll add in module 2. So we'll keep adding our requirements till we get the final product. So this is kind of incremental, module 1 plus module 2, module 3, like that. So that's why it is incremental model as well. So it is iterative plus incremental. Now there are few terms, guys, and different meetings are there in agile development model. So let's talk about them in detail. What are those different terms we have? So sprint we have discussed. Sprint. So it is nothing but the modules we have divided the task into different modules, and each module is of 2 weeks. So that is nothing but the sprint. We'll plan, design, develop, test, release, and get the feedback. So this is sprint. Now we have Scrum. What do you mean by Scrum? Basically, in agile process, we have to follow the agile process, we need to follow certain framework. So Scrum is nothing but a framework that helps the team work together, or it is a work culture to follow the agile development model. So that is Scrum. Now in Scrum we have Scrum Master. Before that, owner product owner. So who is the product owner? So it could be the head from the marketing team who deals with the customer, or it could be from top management uh, individual as well. So who handles the requirements from the customer, who talks about the product with the customer, is called the product owner. Now we have Scrum Master. Scrum Master. So what do you mean by Scrum Master? So it can be project manager, or project manager can be Scrum Master. But the difference is manager handles different projects at the same time, and Scrum Master is particularly for this particular project, for this particular Scrum. So that is Scrum Master. Now we have user stories. What do you mean by user stories? User story. So user story is nothing but the requirement which we got from the customer. Like, we have divided them into different sub requirements. We got some requirements from the customer, and we have divided them into different features: X feature, Y feature, Z feature. So one user is, one user story could be a combination of two features, or uh, one feature, or it could be one plus two feature. If it is like a small feature, then it may have only one feature. If it is like if it is big feature, then it may have only one feature. And if it is kind of small requirements, if you have small requirements, multiple requirements, then it could be uh, multiple features. So that is nothing but the user story. Now what next? We have product backlog. Product backlog. So what do you mean by product backlog? So product backlog is nothing but the combination of different user stories we keep in the product backlog. From there, we'll pick and plan for the particular sprint to develop that requirement. So that is product backlog. You can say the requirements are split into user stories for any particular sprint, and user stories are picked from the product backlog. Now what is next? We have epic. Epic. What do you mean by epic? So epic is kind of again the same thing, but it has large number of requirements in epic. So we have large number of requirements in epic, and this product backlog is for particular sprint. We keep all the user stories there, and we pick it from here. But whereas the epic contains different requirements, so we contain, it is also a combination of different user stories, but maybe for different sprints, like sprint 1, 2, it contains all those requirements in epic. Another point is story point. Another term is story point. So what do you mean by story point? So it defines the complexity of the user story. So it defines the complexity of the user story with respect to dev and testing team, like how complex the particular user story. And the next thing is swag. Another term is called swag. So basically in swag, what happens is it is way to compare the size, time, and effort. Size, time, and effort to develop any particular user story. Size, time, effort. Now we conduct different meetings, guys. So one of the meeting is sprint planning meeting. Sprint planning meeting. So what do you mean by sprint planning meeting? So Scrum Master conducted this meeting before the start of the sprint to discuss about the user story that can be covered in particular sprint, and the timeline of the same would be discussed in this. The timeline for the same would be planned in this sprint planning meeting. Now another term is burn down. Probably you might have heard that burn down. You are burn down. So what do you mean by burn down? So it is the can say that it is the graph between time and work, which shows that how much work is remaining for the project. It is shows that how much work is remaining for the project between time and work. This is burn down. And another term we have burn up. Burn up and burn down chart. Probably you might have heard that. So how much work is done, how much work has been completed is called the burn up, and whatever how much work is remaining is called burn down. Now we used to have daily stand-up meeting as well. Daily stand-up meeting or scrum meeting. This is also called scrum meeting. So what happens here is every day we need to have this daily stand-up meeting where we'll discuss like how much work has been done yesterday, what the work we have done yesterday, what we are doing today, and what we're going to plan for tomorrow. So these are all things discussed in this scrum meeting. So sometimes product owner is also joining this meeting, but scrum master conducting this meeting to discuss about the progress about the project. And we have what else we have sprint review meeting, guys. One more meeting we have sprint review meeting. So this sprint review meeting is conducted at the end of the once sprint is completed, we conduct this sprint review meeting, so where we'll discuss about how how it was the previous meeting. So this is optional meeting actually, sprint review meeting. So at the end of the sprint it is conducted, but there is one important meeting, that is sprint retrospective meeting. Sprint retrospective meeting. So what happens in this sprint retrospective? So at the end of the sprint, or when we have started the new sprint, we conduct this sprint retrospective meeting where we'll discuss like what went wrong in the previous sprint, what went good, what went well. So all these things discussed in this sprint retrospective meeting. And at last we have defect triage meeting. Defect triage. I can write here defect triage meeting. So what do you mean by that defect triage meeting? So here, let's say we have 2 weeks of sprint cycle, 2 weeks, right? So at the end of the first week, we'll conduct this defect triage meeting. So in this particular meeting, the dev team, testing team, probably product owner is also joined this meeting, and we have a scrum master. So here we'll discuss about the progress, like how many defects are open state and whatever defects we have closed. But basically we'll discuss about how many defects are in open state, and we'll prioritize them to fix them as soon as possible. And in case if any defect is not important, then we can defer it to the next sprint if it is not important. So do not worry about the defect related things, guys, like what you may be defer the defect, or how to prioritize, how to give the severity to the defect. We'll discuss in defect life cycle later on. So these are all different terms we use in Agile development model and different meetings we conduct in Agile development process model. So in the next slide, I'll revise like whatever we have discussed so far, guys. Most of the points I have covered in this particular slide, but I have already mentioned in the notes in the form of notes. So we'll discuss in next slide. So let's get started. So Agile methods breaks. What do you mean by Agile development model? Okay, so Agile methods break the task into smaller iterations. We have seen that parts to directly involve long-term planning. We have seen one complete 1 year project. The project scope and requirements are laid down at the beginning of the development process. So we have divided into different modules or sprints to develop them. All the team members should work together to deliver a quality product. So this is the main focus of Agile development model. Management is also involved continuously in this project. So we have product owner, Scrum Master, dev team, and testing team, and along with management also involves, higher management also involves in the Agile development process model to follow the process, to follow the complete project. It is one of the most widely used process in software development world, as it helps team to deliver the work faster in small increments with less issues. So this is the main agenda of Agile development model. Now we'll just recap what we have done in Agile process. So customer satisfaction by rapid continuous delivery of useful software here in Agile process. So we can monitor the project progress every day. Every release is implemented in iterations or sprints. So this is what we have discussed. Every iterations or sprint consists of 2 or 3 weeks in general. So it depends on project to project, company to company. Like it could be, I mean, it mainly it's, for 2 or 3 weeks. In some companies, they used to follow in 1 week sprint cycle as well. However, the sprint duration varies from project to project and also sprint to sprint as well sometimes. Many meetings were involved in this agile process to know the progress of the release in each sprint. Now these are the different terms, guys, which we have already talked about, like product backlog. User stories requirements are split into user stories will be added here in product backlog. For any particular sprint, user stories will be picked from product backlog and worked upon. Epic, it is the complete feature or requirement which needs to be implemented, that we have discussed. User story, and epic is split into user stories based on the complexity of work involved in order to develop it. User story is generally part of epic. So we have seen in epic we contains all the different user stories. In case of a small feature, it will be a single user story. Story points also we have discussed. So it is measurement to define the complexity of the user story from dev and QA perspective. So basically, what do you mean by story points? So it defines the complexity of the user story, how complex is for development of that particular user story, and how complex it is for testing purpose. So this activity will be done in sprint planning. Burn down chart. So we have seen burn down and burn up. So this is pictorial representation of time and work. Pictorial representation of time and work. Team needs to burn the hours on daily basis for the work accomplished against the task. Different agile meetings also we have discussed. So sprint planning meeting at the beginning of the sprint cycle, we used to conduct the sprint planning meeting conducted before the start of the sprint to discuss the user stories that can be covered in the particular sprint, and the timelines for the same would be planned. Daily stand-up or Scrum meeting. It is conducted to know the work done by each in the team. Mainly the below things are discussed. So what work we have done yesterday, what work is planned for today, what work is planned for tomorrow, and any impediments to work to complete the work. Impediments means any obstacles or any problems we are facing to complete the work. Will be discussed in this particular daily stand-up meeting. And we have a sprint review meeting is conducted at the end of the sprint to discuss the progress and where does the team stand for the sprint. However, this is optional meeting, as I have discussed earlier, which is conducted based on the project companies as required. Sprint retrospective meeting. So this is an important point or important meeting is conducted once the sprint is completed and next sprint got started. Following things will be discussed, like what went well in the last sprint, what didn't fail in the last sprint, and what can be done to improve uh, or perform well in the ongoing sprint. So these are the points which we discuss in retrospective meeting. Defect triage meeting. So this is an important meeting. Is conducted to review and have a proper action on the defects, which I talked about. Dev team, testing team, and sometimes product owner also will be involved in this meeting. Defects identified in the particular sprint will be triaged and assigned to respective team or defer sometimes depending on the defects. So sometimes any defect is not important to fix, so we'll defer it for the next sprint. So what are the different advantages of agile process, guys? So customer satisfaction by rapid continuous delivery of useful software, and working software is delivered frequently. So this is an important point about the agile development model. And quickly release are expected if any large requirement are split, so that development and testing is completed in the week scheduled. And customer, developers, and tester constantly interact with each other. So these are some advantages of agile development model. Now, yeah, daily cooperation between business people and developers. So these are some advantages of so that when we have such advantages, then we can deliver the software very frequently to the customer. Now let's talk about some of the disadvantages of agile model. So sometimes in agile methodology the requirements is not very clear, hence it is difficult to predict the expected result. So it happens sometime when we don't have the clear requirement from the customer. In few of the projects at the starting of the software development lifecycle, it's difficult to estimate the actual effort required. So since there is an ambiguity in the requirement, so it is very tough to estimate like how much time it will take to develop, for testing, all those things we cannot estimate properly. Because of the ever evolving feature, there is always a risk of everlasting project. So if requirements keep changing, if you are not capable enough to handle those requirements, so then in that case it will be very difficult to handle the project. For complex projects, the resource requirements and effort are difficult to estimate. If it is kind of big project and complex project, and so in that case we are unable to handle the things properly. And these are some certifications, guys, about the agile. Like we have certified Scrum Professional, certified Scrum Master, again Agile Certified Coach, we have Agile Certified Practitioner, and Safe for Agilist. So these are different certifications we have. If you want, we can discuss more about I'll create a separate video on this, like different agile certifications. So this is all about agile process, guys. So I'll keep the notes in my blog later on. So please, if you like this video, please like it, share it, and comment if you have any questions. And please subscribe this channel if you haven't done so far, and click the bell icon to get the notification for upcoming videos. Thank you so much. Have a nice day. Bye bye.
Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about Scale Agile Framework or Safe Agile. So this is agile process or agile framework which we follow at enterprise level or company level. So I'll take you to my system directly, guys, where we'll discuss more about Safe Agile. So let's get started. So guys, let's talk more about Scale Agile Framework. So you can call it as SAFe. And let me just give an introduction of Scale Agile Framework. So in the earlier video, in the previous video, we talked about Agile process and Scrum. We talked about Agile. So what do you mean by Agile? So let me just recap like what we have discussed in Agile and Scrum. So Agile is a mindset or the way of working the things, or you can say couple of things which we discussed, like mainly it focused on the delivery of the software to the customer, and the second thing is the capability of handling the requirement change. So these are the two important things in agile principle or agile model. And what do you mean by Scrum then? So Scrum is a framework based on agile principles. So these are the two things which we talked about. Now if we talk about SAFe, so it is an extension of Scrum. It is an extension, or it implements Scrum 8 enterprise level, or you can say company level. So since Scrum is framework, so SAFe is also a framework, Scale Agile framework, which implements the Scrum at organization level. Another definition could be like Agile handles the small projects within the organization, and if you talk about SAFe, it handles the large complex projects at organization level. So when we talk about organization, so Scale Agile framework comes into the picture. Now there are three segments, so hope it is clear guys, the difference between SAFe, Scale Agile framework, and Agile or Scrum. Now if we talk about Scale Agile framework, so there are three segments we have: portfolio, and we have another one is program, and the last one is team. So we can divide Scale Agile framework into three segments: the portfolio level, program level, and team level. So here, who handle this portfolio? So we have portfolio management team. Portfolio management team. So basically, it is like top level, or you can say governing body of the company. They will take care of this portfolio management. So basically, they understand the current business of the company, and they work with the clients to get the requirements. So large number of requirements, right? At larger scale. The big picture is portfolio, right? At top level. So basically they get the business epics over here. So in the last when we talk about Agile, so epic is nothing but the collection of user stories. So the portfolio management group will collect the business epic. So this is the responsibility of portfolio management group. So they will get the requirements, and they will create the business epic over here. They will collect all the requirements from the customer. Now the second level is program. So to implement those business epics into uh, features, we have this program level. So who will take care of this program level, the second level? So here we have release team or release management group. So we have here release management group, who handles the features which needs to be implemented. So we'll get the business epics from the portfolio management group and convert them into features here in program. And this is also called agile release train. This level is also called agile release train. So this is the first level, Now this is the second level. Now the third level is team. So here the engineering team will work. Team to will work to get the to implement all the features into convert features into user stories. User stories. So we have seen what do you mean by user story. So it may contain one feature or multiple features based on the requirements, the size of the requirement, uh, the size of the work needs to be done for particular feature. So the engineering team involvement. I mean, it involves dev team and testing team. So actual implementation is done in this by the engineering team. So these are the three levels of Agile framework, guys. Scaled Agile framework. Top level, middle level. This is the top level, and this is middle level, and we have bottom level. If I draw a pictorial representation, so it will look like. Let me just draw it. So it will look like. So let's say if we have different releases over here, release 1, release 2, like this, release 3, release 4. Now these releases will be, this is kind of product, and this product. So this is handled by the last team, which is engineering team, and this will be handled by the middle level, or you can say program or release management group, and in a broader way, in the large picture, which will handle by the portfolio management group. Portfolio management group, which is nothing but the top level portfolio. So this is about the different segments in Scale Agile framework. Now we have some core values in Scale Agile framework. Core values. So what are those core values? So the first one is alignment. Alignment. So what do you mean by alignment? So what happens here is we need to understand the current state of the business and planning for the upcoming projects, and understands the sets the goal in this particular alignment, and all the levels should be aligned to this whatever we goal set for the company. So all the levels like top level, middle level, and bottom level, all should be aligned to the core values of the Scale Agile framework. So that is the first point. The second one, we have built in quality. Built in quality. So what do you mean by this built in quality? So basically, in Agile principle, we have seen that deliver the rapid delivery of the software to the customer. Now, along with the delivering the software, we should also maintain the quality as well as some add some business values to the customer. So that is built-in quality. That comes under built-in quality. What is the third point? Transparency. Transparency. So in all the levels should be transparent, guys. So discuss all the what is the business value of the company, and yeah, so all the levels should be transparent enough to discuss about the current business scenarios, and discuss about the upcoming projects within the organization. And fourth point is program execution. So what is the meaning of this program execution? So this is the heart of Scale Agile framework. So here we mainly discuss like how what how to deliver the software to the customer, like the main release, the releasing of the software to the customer. So that comes under this program execution. Like along with the it's not about just releasing the product to the customers. What value we are adding to the uh, what value we are adding to our business. So that is the main idea about this program execution. Now the fifth point is leadership. So this is an important point. What happens is it requires some leadership behavior to follow this agile framework. So leader can change the system. So this is an important part of scale agile framework. So these are the 5 core values of scale agile framework, guys. So we have alignment, we have built-in quality, transparency, program execution, and leadership. So this is about scale agile framework. So in the next slide I'll talk about we'll just recap like what we have discussed so far. So let me take you to the next slide. So what is scale agile framework? So it is known as SAFe, as we have discussed. This methodology is an agile framework for development teams. The framework is divided into 3 segments. So we have talked about team, program, and portfolio. So this is the top level, this is the second level, and team is the bottom level. Now following are allowed in SAFe. To implement agile software and systems in enterprise level, gives detailed guidance for work at enterprise, designed based on lean and agile principles. So we should follow the agile principles, designed to meet the needs of organization. So these are the 4 things which we discuss in this scale agile framework. So what are the benefits of scale agile framework? So it is lighter in weight and simpler. Also, it can be used to handle large size streams. Few of the key benefits are listed below. Increase the productivity. So when we follow this scale agile framework, it increases. When we use this scale agile framework, it increases the productivity. Helps in increasing the employee engagement and job satisfaction. So this is an important point, guys. So it increases the employee engagement and job satisfaction, because here the involvement of all the levels, like we have top level, middle level, and bottom level. So all teams will be in a synchronized in a particular sync, right? And they will work together to achieve the goals. Decreases the time taken for the time to market. So if you follow simple agile process or normal software development life cycle, so it will be like this. Now if you follow this scale agile framework, so it takes less time to deliver the software to the market or customer. Increases the quality. So it increases the quality as well as some value adds to the business. So this is the benefits of scale agile framework. Now what are the different project management tools, agile project management tools we have? So we have ServiceNow, we have Rally software, Spira plan, we have Target Progress, Plan View. So these are some of the project management tools, agile project management tools. So this is all about scale agile framework, guys. So this is an introduction. It's there is a huge topic like scale agile framework if we talk about. This is just an introduction. So please like this video, share it, and comment if you have any questions. And thank you so much for watching this. Have a nice day. Bye bye. Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about an important topic, that is shift left testing in Agile methodology. So what do you mean by shift left testing? So shift left testing is nothing but when we do the testing as early as possible in software development lifecycle is called shift left testing. So let me give you an example. So let's say this is the duration of my project. This is the starting of the software development, which is point A from the requirement analysis, and this is the end point of software development lifecycle, which is the release of the software to the customer. So this is the entire duration of the software. So what happens in shift left testing is we'll try to move the testing as early as possible in the software development lifecycle. So here in this case, this is the point A and this is point B. So we'll move towards point A at the beginning of the software development lifecycle. So this is shift left testing. So I'll take you to my system, guys, where we'll talk about like why we go for shift left testing and what was the problem in earlier software development life cycle when we when we didn't perform shift left testing. And I'll also talk about like how to move towards shift left testing and what are the benefits of shift left testing. So let's get started. So guys, let's talk about shift left testing in Agile. So before I proceed with shift left testing, let me just talk about like what happens in earlier, how we do the testing in earlier software development models. So take an example, traditional software development model, how the testing is carried out in earlier software development model. So take an example of waterfall model. So we have different phases in waterfall model, like we have requirement analysis and feasibility study, we have design, then coding, then we have testing, release, and at last we have maintenance. So these are the different phases are involved in traditional software development model like waterfall model. Now here if you see this diagram, testing is carried out just before the release. So testing is just before the release, so release would be delayed in case if you get the some issues, right, just before the release. So in case if you get any issues or defects, so we won't go for release until those defects were fixed. So that is the biggest problem in this approach. Now how it looks like if you draw a chart between testing in this axis, let's say this is testing and this is software development life cycle. We have requirement analysis here, design, coding, testing, and release. So earlier testing will be like this, we put effort, testing effort just before the release. Here you can see that this is testing. So what are the different drawbacks when we follow this approach, right? So in case if you get the issues like defects just before the release of the software, so that will take time to fix those defects. So these are the points. We get unexpected issues just before the release. Since we are doing the testing at later stage, we may get unexpected issues and will take time to fix those issues. So cost will be increased. Increase in the cost will be increased, and then delivery time will be more. Delivery time, it takes more delivery time, correct? Because since we need some time to fix those defects, so definitely the it increase the time to deliver the software to the market or to the customer. So this is the different like this is about the traditional approach when we follow the waterfall model or any other software development model. So these are the different problems we face when you follow this approach. Now what happens, why we go for shift left testing? The question arises here is why we go for shift left testing. So basically what do you mean by shift left testing? So it is a practice intended to find and prevent defects early in the software development life cycle process. So we do the testing as early as possible. So let me just draw a diagram like we have created the draw the chart earlier. So here we have this is testing and this is my software development life cycle. So we do the testing, we put the testing effort as early as possible. So later on we do the less testing, we not later we no need to do a lot of testing effort later stage of software development life cycle, since we have already put so much effort at the beginning of the software development life cycle, and during this phase only we find so many defects and get them fixed from the development team. So this is the biggest advantage of shift left testing. Now question comes here is how to move towards shift left testing. So how to move? Next point is how to move to shift left testing. So we have couple of frameworks, guys. So we have TDD, if you have heard about TDD, and BDD. So TDD is nothing but the test driven development, and BDD is behavior driven development. So what happens in TDD is we first write the test cases, and based on that we implement the software, right? Implement the coding later stage based on our test cases, like what. So it is, this framework is driven by the test, that is TDD. So we have started testing from the beginning, like we have written the test cases, and later on software is getting developed later stage. So in that case, we put the testing at beginning of the software development lifecycle. And BDD is an extension of TDD, which is behavior driven development. So BDD is nothing but where we write our testing steps or scenarios in plain English language, American language, probably you might have heard that. And so this is about TDD and BDD, guys, and already I have covered in my BDD Cucumber framework series. So please go to my playlist and talk. I mean, you can learn so much about TDD and BDD. Now, if we talk about different things which we do when we talk about like how we move towards shift left testing. So different things include like we create test plan and test strategy document very early in the software development lifecycle strategy. So test plan is nothing but a document which has a scope, which defines the scope and objective of the test and approach. So it is a document which defines scope, objective, and approach of the testing. And how testing should be done is carried out in test strategy document. So anyway, guys, don't worry about test plan and test strategy. I'll cover them in coming videos. So the first thing is test plan, and we'll create the test strategy document. Now the second is static testing. We do static testing. So this is nothing but the verification. So already I have covered verification. So if you haven't watched the verification part, verification and validation, so please go to the playlist and watch verification and validation video. So we do a lot of effort on static testing, like we do inspection, walkthrough. So these are some static testing methods. So we do all these things at the beginning of the software development lifecycle. Now we create unified test strategy document. So what happens is here is we'll write about unit testing to acceptance testing, all the levels of testing carried out in this test strategy document, like how it should be done. All those things will be carried out in this particular document. Now another thing is risk-based analysis. So it is carried out to determine likelihood of failure for each test scenarios which we have written earlier. So and this test, because we have already created test plan, test strategy, and test cases, so we can prioritize our test cases, which one we should execute first. So this is about the risk based related analysis. So these are the different things which we follow when we move towards shift left testing. Now what else remaining? Now we need to discuss about what are the benefits when we follow this shift left testing. Testing benefits. So the first thing is it enhances the customer experience. Enhance customer customer experience. So we regularly get the feedback from the customer, so it enhances the customer experience. And scope for the implementation of test automation as well. So that is and another thing is, before that we find the defects, find defects early in the life cycle. So that is one of the advantage. And the cost will be less cost. And test coverage, it increases this test coverage because we have started the testing from the beginning, so the coverage will be more in this approach. And what else? Delivery speed will be more, delivery of the software, delivery speed more. And what else? Yeah, automation, scope for automation, why? Because since we start the testing from the beginning of the software development lifecycle, so it enhances the scope for the automation, because build gets gets stable at that particular point of time when we go for automation. So it enhances the scope for automation. And what else we have? It increases the quality. It increases the quality of the software. So these are the different benefits when we follow shift left testing, guys. And yeah, one more is less production issues. The 8th point, less production issues. So I talked about 8 different advantages of shift left testing. So first one is enhance customer experience, find defects early. Second, less cost, test coverage will be more, delivery speed is more, scope for automation, increases the quality, and less production issues. So these are the different advantages of shift left testing. Yeah, so this is all about shift left testing, guys. So this is an important topic I wanted to discuss. So in case if you have any issues, or if you have any questions, then please write me back. Please put in the comment box. And yeah, please like, share this video, and subscribe to this channel, and click the bell icon to get the notification for upcoming videos. So thank you guys for watching. Have a nice day. Bye bye. Hello friends, welcome back to another video of Automation Test Insider. So today I'm going to talk about prototype model. So what happens in prototype model? So basically, based on customer requirement, we create a prototype, or you can say dummy model, based on their requirement, and we'll test it and present it to the client. And based on their reviews and their feedback, we go for the actual implementation of the software. So this is how it happens in prototype model. Now question arises here is why when we use this prototype model. So when customer is new, or if they are not sure about their requirements, then we go for this prototype model. Now I'll take you to my system, guys, where we'll discuss more about prototype model. So let's get started. So guys, let's talk about prototype model. Before I talk about what I mean by prototype model, and when to use prototype model, and what are the advantages and disadvantages of prototype model, so before that, let me talk about the different stages in prototype model. Like normally when we follow any software development model, there are certain stages, correct? So in the same way, what are the different stages in prototype model? So first of all, we get the requirement from the customer, requirement gathering. So this is the first point in first stage in prototype model. we connect to the customer and we get the requirements from the customer. Now the second point is quick design. Quick design. Why do we do quick design? Because we want to build a prototype. So based on requirements, we develop a design, and based on that we create a prototype. Build prototype. So this is the next step. So what do you mean by prototype, guys? So prototype is where it's kind of dummy protocol, prototype or dummy model, which I have discussed earlier, or you can say replica of the actual software. Here all the functionalities will not work, so we'll showcase like this is how your product will look like to the customer. So it's kind of a dummy model. We create a dummy model based with the help of developers, UI developers and business analyst. We'll just create probably in the image format, or maybe half of the functionality will work, not even half, some of the functionalities will work, and we showcase them some images as well. Like this is how your prototype will look like. Now the next step is customer evaluation. Customer evaluation. So based on the customer feedback or customer evaluation, we go for the acceptance. Okay, if customer accept it, then this is called acceptance. Acceptance or acceptance by customer. Or in case if they want to make some changes on the prototype, suppose they don't like the ideas which we have given in the form of prototype, so what we will do, will refine based on customer feedback, and then again we'll make the changes in the design, and again we'll build the prototype. And once customer is uh, happy with that, if they are okay with that, then that is customer acceptance by customer. Now next is we'll follow the same procedure like we do in normal software development model, like design and then coding, and we have testing and then maintenance at last. Maintenance. So this is the complete procedure or stages in prototype model, guys. And now let's talk about like what are the different types of prototypes. So we have four types of prototypes, prototype model. So just for your knowledge purpose, I'll talk about them in brief, so you can get some idea. So the first point is, the first prototype is rapid throwaway. What happens in rapid throwaway is we give some ideas to the customer, like based on their requirements we give them the ideas, like this is how your actual product will look like. So we'll give so many ideas to the customer, and based on the ideas and their feedback from when we get the feedback from the customer on those ideas, we'll create a prototype, and that will be kind of a quality prototype. So later on we won't spend too much effort to modify on that particular prototype. So this is rapid throwaway. So rapidly we get the customer reviews and feedback, and based on that we create a quality prototype. So that is rapid throwaway. Second is evolutionary 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 prototype. So what happens in this evolutionary prototype? So here we create a prototype initially, and we keep based on the reviews or based on the feedback from the customer, we keep adding on our changes.
that particular prototype, and later on we go for the final design. Like we have seen the typical workflow, or you can say the stages. Like here we have seen, so it is like evolutionary prototype. So based on continuous feedback from the customer, we create our prototype and then we go for the final design. So this is evolutionary prototype. What is third one? So third one is incremental prototype. So this is the third prototype. So here what happens is we get the requirements from the customer. Now based on the requirements we create we divide the task into different smaller modules, and we create separate prototype for each of the modules or tasks. Okay, so like we have p1, p2, p3. So these are the different prototypes we create, and we'll test at our end and get the feedback from the customer. And later on, based on the feedback and the changes we make on the particular on the prototype, like let's say p1, we get it tested from our end and got the review from the customer, and then we made the changes as well based on their feedback. And later on we'll keep adding those prototypes in incremental manner. Incremental means like in this flow only, because we this p1 has certain requirements. It should be built first, and then p1, and then p2, p3, p4, and then we'll combine all the prototypes and we create the final build, final software over here. So this is about the incremental, and the last one is we have extreme prototype. So what happens in extreme prototype is this is basically used for UI development, like for which has a lot of interactions in the UI. So firstly what we do is first we create static pages. We create the prototype for static pages, and then for functionality we'll create another prototype. So incrementally again we do in this way, and we build the final product. So based on customer reviews we make the changes on our UI development, whatever prototype we have developed. So based on the based on the customer feedback we make the changes, and then we go for the final build or final product. So basically this extreme prototype is useful for UI development, as I have discussed earlier. So these are the four types, guys. We have rapid throwaway, the first one prototype, evolutionary prototype, incremental prototype, and extreme prototype. Now from the next slide, let me just recap like what we have discussed so far. So the prototyping model is systematic development method in which prototype is built, tested, and then reworked as necessary based on the customer requirement. An acceptable outcome is achieved until an acceptable outcome is achieved. So this is the idea behind this prototype model. If customer is not having clear understanding of requirement, so as I have discussed in the beginning of the of this video, if customer is new, in the market, or if client is new, and if they are not aware of the, or if they are not sure about their requirements, so in these two cases mostly we go for prototype model. So this is what we have discussed, guys, the process. So requirement gathering, quick design, building prototype, and then customer evaluation, getting the feedback from the customer, refine the prototype based on their feedback, we make the changes on the prototype, and then go for the engineering product. Engineering is nothing but development and testing. So when to use prototype model? So prototype model should be used when the desired system needs to have a lot of interactions with the end users. So this is again one of the reasons we have. Typically, online systems, web interfaces have a very high amount of interactions with end users are the best suited for prototype model, because here we are not sure like what to build, what customer actually wants. So we are not sure about what the client wants. So we create a prototype and we make the changes based on customer reviews. What are the advantages of prototype model? Active involvement. So users are actively involved in the development of prototype model. So early detection of missing functionality. So errors can be detected in the initial stage of the software development process. So since we are developing the prototype, so and we get it reviewed as soon as it is developed, so we can avoid the defects in the early stage of the development lifecycle. Quick feedback. So kicker, user feedback helps you to achieve better software development solution. So since we are building the prototype initially and get it reviewed from the customer, we can make the we can achieve a better software development solution by this process. Flexibility encourages innovation and flexible designing. So this is another advantage of prototype model. Now let's talk about disadvantages. So this model is costly and time consuming. Why costly? Because we are building we are putting effort to build prototype, and then time consuming. To build a prototype will take more time, right? So it has poor documentation because of continuously changing customer requirements. So we need to do a lot of documentation, guys. So it is not a quality documentation because of the continuously changing the requirements. There may be too much variation in the requirements, so this is another disadvantages. So this is all about prototype model, guys. So please like this video, share it, and comment if you have any questions or if you want to discuss anything. And please subscribe to this channel, click the bell icon to get the notification for upcoming videos. Thank you so much. Have a nice day. Bye bye.
Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about hybrid model. So what do you mean by hybrid model? So hybrid model is the combination of two or more models, and later on we'll modify as per our requirement. So this is called hybrid model. So I'll take you to my system directly, guys, where we'll discuss more about hybrid model. So let's get started.
Guys, let's talk more about hybrid model. What is hybrid model? So hybrid model is the combination of two or more primary models and modifies them as per business requirements. Two or more primary models. So we have primary models like waterfall model, we have spiral model, V&V model, and prototype model. So it is the combination of either of two primary models and combined together to get the hybrid model. So basically, when we want the features of couple of models in a single model, it's called hybrid model. So let's talk about what are the examples of hybrid model. So when we combine spiral model with prototype, then we can call it as hybrid model. Another example could be V&V model and prototype model. So these are the two examples I have listed down here. Now, when we go for hybrid model, when a lot of collaborations or interactions required between teams, then we should go for hybrid model. Dependency between the modules. So let's say for any particular product we have different modules, so and they are dependent with each other, then we should go for hybrid model. Unclear requirements. So if client is new to the market and if they are not sure about their requirements, then we should go for hybrid model. So generally we combined, I mean in hybrid model we combined with prototype model. So I have talked about prototype model in the last video, where if customer is new and if they are not sure about their requirements, then we go for prototype model. So here also the same thing, when we have unclear requirements, then we should go because in hybrid model we generally combine with prototype model, as I have given in the example with spiral with prototype and V and V model with prototype. Organization is trying to transition to agile model. So this is another example when we go for hybrid model. Now let's talk about, guys, spiral and prototype, how we can make how we can combine spiral and prototype to make hybrid model. So already I have spoken about spiral model. So if you haven't watched that video, guys, so I would recommend please go through that video first. I have provided all the links in the description box of this video, like complete playlist about SDLC process, SDLC models. So please go and watch the spiral model and please come back to this video so that you can understand better. So let's talk about spiral and prototype, combination of spiral and prototype. So if you remember, we have 4 phases in a spiral model. So the first point is planning. Planning phase. The first one is planning phase. Second phase is we have risk analysis. Risk analysis. Third point is implementation. All these points already I have discussed, guys. What are the different phases in spiral model? And if you watch spiral model, then you will come to know. And the fourth one is evaluation the software by customer. Now what happens in planning phase is when we combine spiral and prototype, here is first we build the prototype. We'll create a dummy model prototype. So if you haven't watched prototype as well, prototype model, then please watch the prototype model. So let's say we have different modules, right? In spiral model we work in iterations. So let's say I'm planning to work for module A. Now what we'll do, the first we'll build the prototype for module A. We'll build the prototype for module A and we will test it. The tester will test it, and then we go for review from the customer, and then last one is approval from the customer. So these are the 4 phases we follow to create the prototype. And can join like this. So currently I'm planning for module A in spiral model, guys. Module A. So this is module A. Now what happens is in planning phase, generally we get the requirements and all. Will analyze the requirements with the help of BA. So in this particular planning phase, we have created the prototype. We have get it done the testing and get it reviewed from the customer. And we if you get the approval, if you don't get the approval, then again we have to revise our prototype, and then again we follow the same procedure. Once it is approved, then this phase is passed. We can move on to the next phase, which is risk analysis. Once risk analysis is done, so we'll follow the same which we have followed in spiral model. So risk analysis, we do the risk analysis for module A, and then third is actual implementation of the product or project. So we'll do coding and testing here. Coding implementation is nothing but the coding and testing in this third phase of spiral model. Now this will evaluate, the customer will evaluate, give the feedback about the module A. If they want to make any change, then they will revert it back to the developer. Otherwise we will release it. Okay, because coding and testing is everything is done, so we will release it, and based on their feedback and customer reviews, we implement those in the next module. So this process will keep going on till we get the final build. So this is how it happens in spiral when we combine spiral with prototype. So this is the extra things which we are doing here to create the prototype, and when we combine with spiral model. Now let's talk about the next example, V and prototype. So how it happens in V when we combine V model with prototype.
So I need to draw this V model, V shape, and this side is the developer side, and this is the testing side, or you can say this is a software development life cycle, and this is SDLC. So if you haven't watched V model also, V and V model, then please go and watch V model as well, V and V model, and then come back to this video. So how it happens in V model, we get the requirement from the customer CRS in the form of CRS, and then we'll convert that into BRD, and then I'm skipping that as of now, like BRD, convert that into BRD. We will directly go for the SRS. So that will be converted by technical team, and with the help of BA, that will be converted to SRS and system requirement specification, and at this particular point of time we'll create the prototype. Okay guys, and this is given to the development team as well as testing team, and we'll compare CRS and SRS when we create the system test plan, sorry, acceptance test plan, and we'll create the acceptance test cases. If you remember V model, we used to prepare acceptance test plan and acceptance test cases, because this will be my acceptance level. The level of testing is acceptance level. We'll come back here for the acceptance testing later on. So just understand, like we do acceptance, we create the acceptance test plan and acceptance test cases over here. Now what happens is the next sorry, we have with the help of CRS we create the acceptance test plan. Now the next point is, will the developer created the prototype here. Now here, this is the next level, which is system test level. Now what happens is, here is we create this system test plan and system test cases. We'll compare SRS versus CRS, and we'll go for, here we go for CRS only, customer requirement specification, or you can say BRD, and here we go for SRS versus CRS. We'll compare both the documents, and here, because since prototype is created already guys, so we will test it, and if you find anything in the prototype, like any defect or anything, then we will revert it to the development team here, and because here we'll test the prototype as well. Now what happens here is, again they will create the prototype, they will revise it and get it back to give it back to testing team. Now what happens, the next point is, when we go for the client review. So the next point is here, client review. Client will review the prototype. So if everything goes well, then we go for the next step, otherwise they will revert it back to the development team for again designing the prototype, and then again we follow the same procedure, like we'll get it done the testing, and then if anything comes up, then we'll again go for go to the development team, and yeah, we'll revert it to the development team, and again they will give us for the testing. We'll get it approved from the client. Once it is approved from the client, then we go for high level design. Okay guys, so the next level here is integration level. Integration test, and here on this particular level, what the testing team will do here is integration test plan. They'll prepare the integration test plan and integration test cases, and this level of testing is integration test. Will perform the testing later on,
only, but this level of testing is called integration testing. We are ready with integration test plan and integration test cases. Now what happens, the next is, here we'll go for the low level design, LLD, low level design. Now the next thing is functional testing. Here functional testing or functional test level. This is the functional test level. At this particular level, what we'll do, we create the, we'll come up with the functional test plan and functional test cases on this particular level. When developer developed the low level design, now they will do the actual coding here, because designing and everything is done, so they will do the coding, and developer will do the white box testing, or developer or white box tester will do the either the white box testing or unit testing. So this is unit level. So now like this, and once software is given to the testing team, now what we'll do, we got the build, integration testing, unit testing is done. Now we'll go for the integration testing, because already we have functional test cases and functional test plan and functional test cases. Then if everything goes well, if you find any defect, we'll revert it to the development team, and if everything goes well, we'll go for the integration testing. Here we are ready with the integration test plan and integration test cases, and then we go for system test cases, system level testing. Here we have already ready with that system test plan and system test cases, and then finally we go for acceptance test cases, acceptance testing. Here we have already done ready with the acceptance test plan and acceptance test cases. So we'll execute the test cases whatever we have written on particular level. So this is how it happens with V and V model and prototype model when we combine together. So guys, hope it is clear. If you have any doubts, then please write in the comment box. I'll clear it. Now the next we'll talk about the advantages of hybrid model. So the hybrid model is highly flexible. So since we are combining two models, so it is very flexible model. In this model, the customer rejection is less because of the prototype. So since we already get the approval for the prototype, so customer rejection will be very less. It is easy to implement because it has flexibility of synchronization. So easily we can sync because it has flexibility of combination of different models, and it is easy to use and apply, especially with small and medium sized project. So this is very useful for the small and medium sized projects, guys. Now let's talk a couple of disadvantages of hybrid model. So it does not allow usual standards. So since we follow, we combine the couple of models, so usually sometimes we miss the some standards in when we develop hybrid model. For complex projects, it's very difficult to handle. So yeah, so these are the couple of disadvantages of hybrid model. So this is all about hybrid model, guys. So please like, share this video, and comment if you have any questions regarding this video. And please subscribe to this channel and click the bell icon to get the notification for upcoming videos. Thank you so much. Have a nice day. Bye bye.
Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about derived model. So what do you mean by derived model? So in derived model, what happens is we take the basic model, let's say waterfall model, and we will change it as per our customer requirement. So take an example, if you take waterfall model, and like spiral model is derived from waterfall model, or V and V model is also derived from waterfall model. So these are the two examples of derived model, and this is also called customized model because we take the basic model and later on we customize the model based on our requirement. So I'll take you to my system, guys, where we'll discuss more about derived model. So let's get. So guys, let's talk more about derived model or customized model. So this is derived model is also called customized model. So here we'll take a basic model, take an example waterfall model or single model, and change it according to the customer or business requirement or company standards. Is called derived model or customized model. So let me give you an example. So yeah, in requirement in waterfall model, what happens is we have requirement analysis, design, coding, testing, and maintenance, release and maintenance. So these are the phases of waterfall model. So what happens in waterfall model is we cannot go back to the previous phase which are already done, which is already done. So here in this case we have, this is requirement analysis, design, coding, testing, release and maintenance. So once requirement analysis and feasibility study is done, we cannot go back and change the requirement. So that happens in, that was the biggest drawback in waterfall model. Now you can see what do you mean by derived model. So we have a spiral model which is derived from waterfall model only. So this is our traditional model or base model, guys. If you remember, already I have spoken about waterfall model, spiral model, VNV model. So if you haven't watched those videos, then please go and watch those videos. I have provided the link in the description box of this video, the complete playlist. So what happens there is, like, a spiral model is derived from base model, that is waterfall model only, and we have done some kind of customization uh, in spiral model. Like risk analysis is the biggest thing in spiral model. Second thing is we do the module wise implementation of the will implement the software, we'll do the coding, testing module wise. So these are the couple of things which we customize on spiral model. So spiral model looks like this. So we have module 1, module 2, like this. We do the implementation module wise. So that is the spiral model which derived from waterfall model. Okay, another example is V model. Now here also we do the testing as early as possible, parallelly with development lifecycle. So this side is software development lifecycle. Here we have software testing lifecycle. Here you can see we have seen in V model, parallelly we create the test plan, test cases when we go through development phases. So already we have started the testing phase. So this kind of customization we have done on V model. So yeah, this is the example, two example, like spiral model and V model are the customized model because they are derived from the base model. Now let's go move on to the next point. The most significant disadvantage of previous models like waterfall model is that there were lots of customer rejection that happens after the application was developed and there was no involvement of the customer in between the project. So this is the biggest drawback in spiral model, or you can say, sorry, waterfall model and spiral model later on. So yeah, the customer involvement is very rare in that case, less. So that's why again we customize, we go for the another customization, like we have done the prototype, right? So again we got some drawback in spiral model. Here you can see, like I have listed on, I have given the spiral. Waterfall already we have covered, like what are the disadvantages. Now spiral is because customer involvement is very less, so hence they have started the new approach which is known as the prototype model. So again this is customized thing which we have done from the basic model. Like we present to the present a dummy model to the customer, and based on their reviews, their feedback, will develop the actual software, will develop the actual product. So this is a derived model, guys. So let's say what is next. So the spiral example of derived model. So the spiral model is derived from waterfall model, which we have discussed. V model is also derived from waterfall model.
And waterfall model is known as mother of all the models. So whatever model we have, uh, because waterfall model is also called traditional model, so all the models are, you see, more or less derived from waterfall model. So these are the examples of derived model. So this was very quick, guys, because if I mean, for knowledge purpose, this is very important to understand like what do you mean by derived model. So thank you guys for watching. Please like this video, share it, and comment if you have any questions, and please subscribe to this channel and click the bell icon to get the notification for upcoming videos. Thank you so much. Have a nice day. Bye bye.